Hello, everybody. Thank you for joining this workshop, MLOPs with Dataiku, considerations for model deployment and monitoring. My name is Faraz. I'm one of the co-organizers at MLOps World. So just before we begin, if you have any questions, please feel free to ask them in the chat with a queue in front so that we can collect and address them in the end. Also, just a reminder that the talks for tomorrow are hosted on Hopin. You would have received an email earlier today. If not, you can send me an email. I'll send my email in the chat. So without further ado, I'm going to pass it on to Adam for the workshop.
Great. Thanks, Fred. So hi, everyone. This is Adam Gugliciello. I work in solution engineering for Dataiku. I'm super glad to be here with you all today. For those of you who are not familiar with Dataiku, we produce a software platform that enables teams to centralize and collaborate on their data and analytics process, really across the end-to-end lifecycle, which I will be talking about in some detail later. For those of you who aren't familiar with solution engineering, it means that I help our customers adopt our solution and start their journey to what we affectionately refer to as everyday AI. Most recently, I was at MuleSoft, and before that, Datamir. And what I've seen sort of over the last 10, 15 years in the integration and analytics spaces was really a tendency towards large, expensive projects that ended in a report in CIO magazine. Folks spending millions of dollars on hardware and software and data scientists, and really missing the boat when it came to taking prototypes and delivering value to the business. And if you talk to McKinsey and look at the venture beat, they'll all throw some large high 80s, low 90s number about how difficult it is for organizations to produce real business value out of their data science, machine learning, analytics prototypes. And the vast majority of that really comes down to not thinking about machine learning operations until the end. And a lot of what we see is data science teams who have really no true understanding of what happens in ops and what happens in specifically in IT ops, sort of shows up at the end of a large and complex project where they have built a heck of a lot of features. They've done a heck of a lot of data domestication, and they show up to the IT ops team with a pickle file and say, please put this into production. And everybody sort of stands around looking at each other with no real understanding of what it means. And so we here at Dataiku have opinions about what that means. We have put them in a book, which I'll be talking about a little bit later. And we have built them into our product. So I'm going to be showing you a little bit about what we think codifies a meaningful understanding of model deployment and monitoring, and sort of generally MLOps at large into our product. But the concepts here are neutral to the product. We've just done a fair amount of thinking about what that might look like. And so I'll be sort of switching in and out of demonstration as I walk through this talk. So we're going to focus on, as I said, the life cycle, the full data science life cycle. We're mainly going to focus on the back half of this life cycle. What happens after the initial design phase is complete and you're ready to operationalize a machine learning pipeline? We're going to talk about the key concepts and considerations. We're going to talk about the different roles and responsibilities that go into that go into a meaningfully operationalizable production pipeline. Talk a little bit about deployment, monitoring, management strategies, CI/CD, security and governance around lifting inference engines and feature stores into a grown-up pipeline. And like I said, I'm going to be talking a little bit about how Dataiku can help to streamline those machine learning processes and the operations of them. So if you're not looking for that, you're in the wrong space. But let's at a real high level, let's let us establish our terms. Let us define the language that we're going to use as we go forward. Machine learning ops, MLOps, is really a broad and conceptual topic, but I'm going to level set it by using a simple definition to describe what I mean when I say it, and that is the processes and tools that allow organizations to safely and efficiently scale the use of machine learning in production environments. And it's really a dance between two functions, the data science and analytics teams and IT operations, who very often have wildly differing opinions about what operations and what good means. But generally speaking, agree on what the task is keeping them running in a peak, high quality, predictable, and reliable fashion in as controlled a manner as possible, especially in heavily regulated industries like healthcare, finance, manufacturing, where there's both regulations or real, true, serious real-world costs to having models fail or having models act in unpredictable ways, and all of that sort of comes together under the umbrella of MLOps, and I'll be talking about that in some detail in a minute. But as I said, good means different things to different people. And so there's a lot of roles and responsibilities in this RACI chart. It's not just data science and IT operations. You've got your data science teams. Yep, they're there. They want to make sure that the model is performant, that the area under the curve hasn't gotten too big or too small, that the data pipeline is still operating correctly, and that the real world data and the shape of the data as machine learning models have started to affect the real world haven't changed a bunch of assumptions about how this data is arriving. There's your IT ops guys, and their concern is it up? Is it healthy? Is it setting my boxes on fire? What is the cost of my AWS? Is there a sensible amount of memory in use? Do I need to use a bunch of GPUs? Do I have folks using GPUs that shouldn't be and are driving up the cost of operations? Very much about, are the lights on? Is the furnace stoked? You've got your business owners who are always trying to figure out whether or not the return on investment is sane for the amount of work that a given model is producing. They are wondering whether or not a given model, analytic, dashboard, what scoring effort, whatever it is that project is producing, outweigh the cost of developing, and specifically outweigh the cost of maintaining it, especially as real world data changes and as the response to those models, to those real world data change. That is a constant analysis that has to be done about whether it's time to sunset models or develop new ones. And that's just the nature of the feedback loop between the real world and and machine learning models or AI models responding to that. And then you've got your risk folks, the regulatory compliance folks, and they're looking at this from a slightly different lens. They want to make sure that that my models are not acting in unpredictable fashions for subpopulations. As I mentioned earlier, healthcare is very sensitive to the proven fact that people of color and women often have less desirable healthcare outcomes, and they want to make sure that isn't being codified in models. You've got lenders and banks who are very concerned with making sure that there is no bias in risk models or credit approval models, such that they can take that to the likes of a FINRA or an FDIC and prove that what their models are doing, the audit chain around those models is sane, that the folks who have touched those models have done so in a sane and governed fashion. And all of this sort of falls under a fairly large umbrella that is MLOps, with a lot of different moving parts and a lot of different business domains. And we'll talk a little bit about regulatory, reputational, and operational costs for the risk manager a little bit more near the end. when when organizations think about machine learning, they generally think about this cycle. Acquire data, explore it, do some data domestication and preparation on it, do some modeling, assess those models, figure out where your features are wrong, do some more exploration, do some more preparation, and so on and so on, and eventually refine a model to something that you want to, quote, deploy, whatever that means. The data science is generally doing the heavy lifting across this life cycle, from data acquisition through preparation and transformation. There might be some handoff back and forth with a data engineer to access data in the first place. But because this is a pretty prototypical effort, this tends to be relatively sort of loosey-goosey from a standpoint of data engineering. This is really more of an ELT approach, where transformations are applied in order to refine the data prior to model. Once that POC is proven out and accepted, and they make up a cool dashboard and a PowerPoint presentation and convince leadership that this is a thing that they want to do, the code is generally thrown over the wall to IT. And IT and data engineering often spend weeks, if not months, re-engineering the data pipeline, the feature development, even oftentimes the model itself, so that they can operate it. In many cases, completely recoding it to harden it, to do defensive development against weird data, bad assumptions, scale problems, and being able to scale it to real data and not training sets. And for generally, we at Dataiku sort of think about this as a maturity curve, and sort of as you climb the maturity curve, the first few projects that actually make it into flight are operationalized. The data scientist tends to be the on-call expert to contact when things break. And that works for 3 projects, 5 projects, maybe 10 projects, and sort of depends on the size of your data science team. But when you get to 300 or 3,000 models in production, those folks simply can't scale like that. And that level of dependence on the data science function becomes unsustainable, and you very much need something that is much more systematic. So the full picture of this is wider, and it really represents more than that simple framework with an input and an output. It really is a software delivery lifecycle with constant refinement, data engineers handling access and low-level ETL at the data source level to smooth data acquisition. You've got your data analysts and your maybe doing some initial data blending and wrangling and sort of general domestication to ensure that the data sources that data scientists are using are in compliance with the top of the house reports. We've got our data scientists spending more time on the piece of the puzzle they love best, which is the sort of center of that circle. And then IT operations is incorporating the final developed solution into established MLOPs frameworks, their overall log management and audit management. They're looking at things like their horizontal cloud compute for scale, using things like AKS or EKS or OpenShift to not just support real-time models and real-time inference engines that they're potentially integrating to CRM solutions to inform sales teams, or potentially integrating with MLOps with manufacturing ops to do things like tune bioreactors and ensure that the production of special yeast is optimally tuned to produce biomass in the bioreactor and then to express chemicals. There's a fair amount of integration that goes on in that operationalize and deploy. And whether you're doing batch for report generation or large scale scoring, or real-time operations for deploying inference engines and the feature models that support those inference engines, it's a very different creature. And so as you scale up, more and more separation of duties becomes possible. And in an ideal state with the right platform and tooling and processes, the separation can occur without sacrificing collaboration and transparency. So as I mentioned, normally I would sort of switch into a demo here if I were selling Dataiku, but I'm going to really focus on that last half and the bottom half where we operationalize and deploy these models, and where we understand and come to trust these models. They really fall together. So for that last leg where the operations engineers take over, it's not to say that the data scientists, engineers, analysts never come back into the loop. That's absolutely true. They're going to come back when things change, but also when models start to report that they have started to drift, that their data has started to drift, or that bias is being detected. You need the folks who built the thing to come back and really understand it. But the more self-sufficient the ops team is to manage the product in production, the better. And there's a bunch of reasons for that separation of duties. I mean, the first is basic, right? It's a matter of bandwidth. Data science teams are small. They generally have 3 times the number of available open job openings to folks who are applying to it. And so that talent is scarce, and it's easy for operationalized models to overwhelm their ability to produce new stuff. But the second thing is that I don't want designers coming to change the oil in my car. Like the reality is that, the mechanic who keeps my car running is a very different person from the person who is sculpting models in a wind tunnel. And that's a very different set of skills. And the folks who really understand IT operations and ML operations are often not Python developers or not statisticians, and don't understand machine learning and AI in a deep way, but need to produce best practices for software delivery life cycles, et cetera. And the third piece is really risk management. And anybody who's been doing IT ops for any amount of time is aware of, like, if it goes into production, no human should touch it, right? Like, seriously, hands off. Production is a no humans allowed kind of place. And so you need separation of concerns, and you need automation around that separation of concerns to meaningfully produce that oversight and governance in a way that you can report that to regulators. So when we think about MLOps, really reliable and robust data ops is absolutely reliable and robust data ops, not just MLOps, but the operations by which data pipelines are processed is absolutely critical for the entire system to run smoothly. An algorithm by itself is useless. It's like a brain. And the data ops is really the circulatory system that feeds it nutrients, that is its lifeblood, and the skeleton and muscles that are the sort of tissue of integrations around it that execute those brain's decisions. And when the model says jump, the whole body of the thing says how high. You can't do that without meaningfully thinking about data operations as part and parcel of that machine learning journey. And so both the data pipeline and the model have to be operationalized for that system to function, regardless of whether you are thinking about this as batch or as real time. Because when we are thinking about this, from a standpoint of sort of predicting, doing real-time predictions, like there's a ton of data elements that often need to be looked up as part of a real-time processing engine, and that needs to be cached so that it can be rapidly accessed in a feature store or as part of a data mesh. And all of that needs to be fed and refed whenever the data is available. You need to be able to evaluate ground truth against that data set. So even your real-time models often have batch components. I say often, always have batch components. And even with a robust data pipeline, the truth on the ground and the data is likely to start to change as soon as you start to change your behavior, right? Like it's a feedback loop between the ground truth of what's happening in the data and and the actual inputs to the model, and you need to be able to constantly monitor and tune that. And so we think there's really sort of three big pieces to the platform around. There's four. There's a meta piece that I'll talk about in a moment when I switch to demo. But it's automating the data and model life cycles so that it's not a point in time and it's not a snapshot. And ideally, I don't have to redevelop all of this in my favorite ETL tool. I don't have to redesign the entire data pipeline and feature stack that is arriving before my model is trained or my model is put into production. I very much need to be able to monitor the model both from a standpoint of the incoming data and have assumptions about the data changed, as well as monitor the actual models themselves for accuracy, monitor their confusion matrix, monitor the amount of real world false positives and false negatives for predictor, so that I know when the model has ceased behaving in the fashion for which it was designed. And then both my batch and real-time data operations and model operations need to be monitored from a standpoint of, is it up? Is it healthy? Is it setting my boxes on fire? Am I getting the expected throughput? Am I getting the expected cost for operations? Do I need some giant machine with a giant pile of memory to be up in order to execute this model? Or is this something that I can scale horizontally in a Kubernetes with relatively small pods that I can deploy horizontally? And so let me talk a little bit about what that looks like with a demo. This is a simple but relatively common flow in Dataiku, showing some data processing pipelines. At a glance, I can see a bunch of stuff about this model. I can see that this is mostly running on top of Snowflake, as indicated by the blue squares. I can see some visual analytics, but I've also got a Python notebook here, and that means that I need to manage the environment and the set of libraries that are associated with that model. I've got machine learning models here that we've trained here in green. I've got a predictor that I'm lifting in a random forest predictor that I want to potentially lift as an API to tie into whatever. This is a sales forecasting model, so I want to maybe tie this into my CRM for my sales folks to be able to make real-time decisions based on individual customers, or maybe I want to turn this into a recommender for our highest value products, built directly into the website, for instance. And so I'd like to thank everybody for their time and attention today. Like I said, if you have deeper questions, we have a booth. We've got it staffed with some folks there who are happy to dig into some of your questions. We also recommend the Introducing MLOps book.
Awesome. Thank you so much, Adam. Once again, a reminder to everybody, the workshop is recorded and will be shared after the summit. And we look forward to hosting you tomorrow on Hopin. Thanks, everyone.